we're going to just begin with some definitions. And I don't know why it's not sliding for me. All right, so the first thing we want to talk about is a population and a sample. And a population is just a collection of all elements. And a sample is a sub collection of members selected from a population. So a real life example of a population would be all of the students at Aiken Technical College, right? That would be a specific population, which would include every single student at Aiken Technical College. Now, when you're pulling information from a population, it's almost impossible to get information from everybody, right? Because you have some people at Aiken Tech, they may be enrolled in the school but haven't taken classes. Their address may be different than what we have. It may be kind of impossible to get in touch with them. So when we talk about population statistics, those are rarely ever captured, okay, because it's hard to get consensus from everybody. A sample is a subset of the members in the population. So a sample would be, let's say this statistics class. You all are a part of the population here at Aiken Technical College. You would be a subset that would represent a population. When you're trying to determine between a population and a sample, right, for a population, we use what's called a parameter to describe the population. And for a sample, we used a statistic. So a parameter describes the population. Okay, that's a piece of data about a population. And a statistic that describes a sample, okay, which is a subset of the population, which should be representative of the population. All right. And I don't know why I just keep closing down. All right, so when we talk about some examples, okay, is this a population or this should actually say parameter or a statistic. The student body at Aiken Technical College, is that a parameter or a statistic? A parameter, right? Because we're talking about the entire student body. And I guess I should have used some different examples. All right, so that would be a parameter. And a statistic would be the number of students in a statistics course. Okay. Normally, when you're determining between a parameter and a statistic, for statistic, you're going to see this word sample, right? And a sample of so many students. That would be descriptive of a statistic. Okay. If you don't see the word sample, generally they're talking about a population. And for whatever reason, my document won't stay up. All right, so I'm going to pull up that handout. All right, and I would like you to do problem number 1. Okay, just kind of jot the answers down. You want to determine whether each one of these values is a parameter or statistic. Okay, A says out of a sample of 977 men, it was found that 76% like chocolate. Is that a parameter or statistic? Okay, so you're going to go through B, C, and D. Okay, determine whether it's a parameter or a statistic. I may need this. All right, so for A, and the key word on it is a sample. Out of a sample, that means that's a subset of a population. Of 977 men, it was found that 67 like chocolate. That would be a statistic, right? Simply because of the word sample. B says using consumer reports. And consumer reports, it tries to, I don't know how many people are familiar with that or not, but it kind of lists, it attempts to get information from every single consumer. Consumer is somebody who buys stuff, so that's supposedly all of us. I've never heard from these people, so. But it says using consumer reports, a random sample of new cars gave an average of 34 miles per gallon. So is this a statistic or a parameter? Statistic sample. C, in a recent sample of 213 people, it was found that 19% do not bathe every day. Statistic for the sample. Right. And then the last one, 24% of vehicles sold are compact cars. Parameter. So a parameter describes the population and a statistic describes the sample. All right, so those were the, okay, so I do have some more stuff here. Okay, next we'll talk about qualitative and quantitative. Qualitative data can be separated into different categories. So qualitative data is descriptive. It gives some quality, some characteristic of a piece of data. Quantitative data, data that can be, that you can put a number to it, right? Anything that you can quantify, right? That would be considered as quantitative data. All right. So here are examples, qualitative or quantitative. The gender of professional athletes, is that a quality or is that like a number type? That's going to be qualitative, right? That's a quality or characteristic, either being male or female. 2, the weights of professional athletes. Is that a quantitative or qualitative? Quantitative, because you can put a number on weight. right? You can't put a number on gender, but you can definitely put a number on weight, right? So the weights of professional athletes would be a quantitative measurement. Okay, so we're gonna go back to, all right, so let's take a look at the second one. All right, and this is from the handout. It says indicate whether the following variables will best be described as qualitative or quantitative. So I'll give you a minute or so to, okay, let's just use four, right? You want to determine if it's a qualitative value or a quantitative value. Okay, so for the first one, age in years, quantitative, right? Because you can put a number to your age. The number on a soccer player's jersey. Now this one kind of tricky. I mean, I wouldn't say it could be quantitative, but when you think of the number on a soccer player's jersey, you think of a number, right? Like number 23 or 2 or 1. But does that number actually have a meaning, let's say, as far as age and years? It doesn't, right? So the number on a soccer player's jersey is a qualitative measure. Is everybody okay with it? Because you can have like number 1, right? I'm number 1, and then you can have number 23. That don't mean I'm better than number 23. Just because my number 1. All right. So that would actually be qualitative. All right, the next one. Habits on an always, sometimes, and never scale. Qualitative. All right. Type of residence. Single family home would be how many families? One. A multi-family home, I guess that would be how many people, I mean, how many families stay in the house. But if it's a two-family home, that would be what? 2, 3 families. So would this be qualitative or quantitative? Quantitative. Is everybody okay with this number on the soccer player's jersey and this type of residence? So even though it doesn't have like an actual 1, 2, 3, 4, 5, it's actually still quantitative because single is 1, 2 family be 2. You can actually put a number to it. Whereas the number on the soccer player's jersey is basically meaningless. All right. So now we're going to talk about discrete and continuous variables. And discrete values are what's called a finite, is a countable set of things. For example, the number of people in this class is finite because we can actually count the total number of people in this class. There'll be no more, there'll be no less. Continuous variables may have infinitely many values. So here's what I mean by that. Between the numbers 0 and 1, like you go 0, 1, 2, 3, 4, between 0 and 1, there are infinitely many values. Does everybody agree with that? You have like 0, you have 0.000000001, and you have 0.00002. There's infinite many values, all depending on how many zeros you put in. All right, so a continuous variable, there are infinitely many possible values. So here's some examples. The number of eggs that a hen lays, is that discrete or continuous?
Wait, what's the question?
Okay. Right here, the number of eggs that a hen lays, is that a discrete variable or continuous? Well, now the number of eggs, is that a countable set of things? So that would be discrete. You can count them. The hen laid 5 eggs or 3 eggs or 20 eggs, however many eggs they lay. It's a countable set. The weight of eggs that a hen lays. Continuous. And this is the reason why. Let's just say if I were to get on a scale that was only out to like 2 decimal places. You know how you get on some scales and it'd be like 238.67. You can get on another scale and it might be like 253. You don't have all the little extra. So weight is like a continuous type variable. All right. Because who's to actually say that you studied exactly 1 hour? Or who's to say you weigh exactly 150 pounds? Right? So like time, weight, those things are considered to be continuous. All right, so I'm going to go back to and I thought there was some on here. Okay, it skips down to number 4. All right, so determine whether each one of these is discrete or continuous. All right, so I'll just give you a second to look at those. The number of hours the students study in a week, the wage per hour, the weight, and the salary. Are those discrete or continuous variables? All right, so let's take a look. So the wage per hour, is that discrete or continuous? Discrete. Because your employer is only going to pay you X amount of dollars. They're not going to give you any more. They're not going to give you any less. The weight in pounds, continuous, right? Your salary, discrete, right? It's a countable set. You're not going to have more. You're not going to have less. Am I missing something? Oh, the number of hours the student studied in a week. Continuous. All right. Time is continuous. Weight is continuous.
Wage per hour was discrete?
Discrete.
Okay.
Right? Because you're going to get paid, let's say, exactly $20 an hour or however much, but it's a countable set, no more, no less. Whereas the number of hours you studied in a week, I mean, you can say you studied an hour, but you might have studied a little bit more than an hour. You might have studied a little bit less than an hour. So time and weight are definitely continuous variables. All right, so now we're going to talk about levels of measurement. And there are 4 levels of measurement, okay, which are nominal. And when you're actually asked to choose if, you know, the variable is nominal, ordinal, interval, or ratio, I would actually go through and ask myself these 4 questions. Okay, nominal data are data that consists of names, labels, or categories. So mainly like qualitative, right? But it has a name, a label, a category. Ordinal data are data that you can put in an order. There's some rank to it, like always, never, sometimes, that kind of thing. For interval data, the difference between any 2 values is meaningful. I'll let you think about that one. There is no true zero for interval data. And then for ratio data, there is a natural zero or a starting point. So the difference between interval and ratio is that for ratio data, there's a true zero. Zero means something. For interval data, there is no true zero or true starting point. So example would be, I guess, temperature. Temperature would be on an interval scale. Because 0 degrees doesn't mean that there's no weather outside, it just means that it's cold, right? So if you think about temperature, 0 degrees doesn't mean that there's no temperature, it just means that it's cold. So 0 is really not meaningful as far as temperature is concerned. An example of ratio data would be if no students came to the statistics course and there were like 0 students, that would mean something, right? There were like no students. Opposed to 0 in temperature, which means that there's no weather or there's no temperature. Okay, so interval data, the differences between any 2 values is meaningful. In essence, there is no true zero. So I'll kind of expand on this once we look at the example. And then for ratio data, there is a natural zero. All right, so here's some examples. Nominal data, survey responses of yes or no. All right, yes or no would be like categories. Colors is a nominal variable because colors just categorize things. Right? There is no color, one color greater than another color. For ordinal data, grades, A, B, C, D, right? That's some rank order. Also have ranks like sometimes, always, and never, right? If you had to rank first place, second place, third place. Those are all ranks. Interval data would be temperature, which I kind of talked about, right? 0 degrees does not actually mean there's no weather. It just means it's cold. Years is also an interval data. So if I talk about years, well, I don't really want to round the board, but this is like, what, 2022? Last year was 2021. And you can go back when I was born, 1972, and then you can go back further than that. But is there a such thing as like 0? So 0 is not really meaningful as far as years. Ratio data would be weights, right? Because something can weigh no pounds. Prices can also be ratio, because you could be given something for free. All right, $0. So is everybody okay with the 4? So when you actually, if I was actually asked to put temperature, label it, I would say, well, is it? I would go back, and I wish I could have both of these up at the same time. Right, I would ask myself these 4 questions. Does it contain a name or a label? Yes or no? If it does, then that's what I have. If it doesn't contain a name or label, then I would ask myself the second question. Can I put it in order? If I can put it in order, it's ordinal. If I can't put it in order, I'll go a little bit further. Is the difference between any 2 values meaningful? If yes, I know it's interval. If no, I would go to the last one. And then for ratio, by default, it has to be ratio, but I would still ask myself, is there a natural starting point? And it should be yes. All right, so I'm going to go back to the handout, and I want you to ask yourself these 4 questions and then determine these. They're not all on one page, but you have to tell the level of measurement, the type of residence. I will go through all 4. The number of children. I will go through all 4. The number of years at a current job, and then habits on always, sometimes, or never scale. All right, so I'll give you a second or 2 or a couple minutes, and then we'll take a look at the solutions. Trying to put it all on one. And just as a hint, each one, they're all four used. No variable is used twice. Right, so one is nominal, one is interval, one is ordinal, and one is ratio. All right, so let's take a look. All right, so for the first one, the type of residence. Example, single family home, multi-family home. So we're gonna start with the first one. Is that some kind of category? Yes. So that would be what? Nominal. Right. So now the number of children. Okay, is that data that consists of names, labels, or a category? No, right? I'm actually reading from this. I wish I could pull both of them up at the same time. So we're looking at number of children, so just to show you what I'm talking about. Okay, it's like for the number of children. Is that data that consists of names, labels, or categories? No. So I'm gonna go to the next one. Number of children. Can they be arranged in some type of order?
But I said interval. I put ratio.
Well, can I rank the order, the number of children? Okay, I can't rank them. So let's go to interval. The difference between any two values is meaningful. All right, so it's on this. I'm trying to put the difference between any two values is meaningful. So if you have 5 children, that means you just have 5 children. You can't, they're not two values. Does everybody kind of understand? So you can't compare it to someone else. You just only doing with the number of children. So that means it would have to be what? Ratio. Because 0 children is no children. All right. So that would be ratio. All right. So you would go through all 4. Let me go back. Numbers of years at a current job. So is it nominal? It wouldn't be nominal because it doesn't categorize anything. Is it ordinal? Can you put it in order? Is it interval? Don't be scared. I mean, is it interval? Why is it interval? Because it's years. And this is why, okay, I want you to see. Let's say I started at Aiken Tech in the year 2000. And now it's 2022. I've been here like 22 years. Could I have started at year 0? I couldn't have started at year 0. Is everybody comfortable with that? So a hint on this one is years, when you're talking about years.
So interval will always be years.
Yes, it'll always be years. For the simple fact that, like I said, I've been here 22 years, and 22 would be, I guess, like ratio if you, I guess because I could have been in no years, right? But if you think about year as far as the calendar year, like 2000 or 1990. There is no 0 year. All right. So years would always be, And then the last one, habits on an always, sometimes, and never scale. Ordinal, because that's a rank order. All right, so is everybody okay with the levels of measurement? I know the interval and a ratio can be kind of sticky, but interval is always years, and ratio data has a true 0. It means something. All right, so the last part of this first half of the module, it deals with a frequency distribution. So I just want to describe what a frequency distribution or frequency table is. It's basically just a table of frequencies or counts. Right? On this first column, we have the data, and this data is in intervals. Right? 40 to 47, 48 to 55, right? On down to 80 and 87. In the second column, we have the frequencies or the counts. So if we look at this first class, right, so these things are called classes. This is the first class, second class, third, fourth, fifth, and sixth classes. If we look at this first class, the lower limit is 40. The upper limit is 47. And there were a total of 11 counts in this first class. Now, what this over here means, I mean, this could be ages of people in a class. It could be a lot of things, right? It just says data. And over here, this is the frequency or the counts. So we're actually going to construct a frequency distribution. But before we do, let's take a look at some definitions. All right, so we have lower class limits and the smallest number that belongs to the different classes. So I wish I can put both of these on the same. Okay, so going back to this example, the lower class limits would be 40. Can you see that? 40 would be a lower class limit, 48, 56, 64, 72, and 80. Those are all lower class limits. Upper class limits would be, the upper class limit for this first class would be 47. The upper limit for the second class is 55, so on and so forth. Okay. All right, so the lower class limit is the smallest number in the class. The upper class limit is the largest number in the class. The midpoint is the value in the middle of the class. So there's actually a formula to find the midpoint. The midpoint is the upper class limit plus the lower class limit divided by 2. Because we will have to find midpoint. All right, so you're going to take the upper class limit plus the lower class limit, you're going to divide that by 2. All right, so let's, for example, if we wanted to find the upper class limit for the first class, I don't know why it's so hard for me to move this. All right, if I wanted to find the midpoint for this first class, I would simply add 40 plus 47, and I would divide by 2. I wanted to find the midpoint for the second class, I would add 40 plus 55, divide that by 2, and so on and so forth. Okay. Now, next we have the class width. So the difference between two consecutive lower class limits is the class width. Right. So I want to kind of explain this, the class width. All right, so what will be the class width for this frequency distribution?
40 to 82. Oh, are you talking about like between the two?
Between a class
Also,
or two classes?
7.
So the class width would actually be the difference in the two lower class limits. So that's what a lot of people do. When you say 47 minus 40, it should be 7, right? But that's not how you want to do it. You want to subtract the lower class limit. So 48 minus 40 is what? 8. So the class width is 8. So think about it now. This is also 8. Because you got 40, 41, 42, 43, 44, 45, 46, 47. That's how many numbers? 8. But if you say, well, 47 minus 40, you did something different. All right. So to standardize everything, to find the class width, you want to subtract the lower class numbers. So it'll be 48 minus 40, which will give you, which is the same thing as 8 up here, but the standardizer we use in lower class numbers. Right, so that'll be the same here. If you want to find the class width is not going to change between the classes. 56 minus 48 is also what? 8. The relative frequency, we're actually going to talk about that when we construct the frequency distribution. It's found by dividing the class frequency by the total of all frequencies. So just to give you an example, let's say we want to find the relative frequency for this first class. First, I would have to add up all of the frequencies in this chart, 11 plus 18 plus 13 plus 8 plus 5 plus 6. And then for the relative frequency, we would divide 11 by the total. And we're actually going to see a live example in a second. This slide was just to present a frequency distribution. Okay, but we're actually going to calculate one in a second. So you would take the frequency for a particular class and you would divide it by the total frequency for that distribution. And the last definition is cumulative frequency, and it's the sum of frequencies for the class and all previous classes. So we actually want to see an example of all of these. Okay. All right, so let's take a look at this. It says calculate the class width of the data and construct a frequency distribution using 6 classes. Now, anytime you actually construct a frequency distribution, they will always give you the number of classes. Enter the lower and upper class limits of each range, and then fill in all the boxes of the corresponding frequency. So first I'm going to start off with a class width. You want to take the maximum value minus the minimum value and divide by the number of classes. So we're gonna have data right here. We're gonna have frequency. And then we're asked to find the class range, the frequency, the midpoint, the relative frequency, and the cumulative frequency. So once we're finished, before on the slide on the lecture notes, it just had like the data in its classes, and then it had the frequency. But we're going to expand that out to find the midpoint. Remember, there was a formula for the midpoint. We're going to find the relative frequency and the cumulative frequency. Okay, the way we're going to start it all off is we're going to have to find the class width. So we're going to have to find the maximum value and the